Hello there. Today we are doing the quadratic formula. You guys did this in Algebra 1, and so it's not unfamiliar to you. The only difference is that we are not using Decimus or a calculator, so the calculations might be a little challenging for some of you, and we're going to be simplifying a lot of radicals. We're not using any decimals. So that might be the other challenge. And we're also going to be having we're also going to be finding some imaginary roots. Remember solving. We have learned different methods of solving in this unit. We haven't gotten to all of them yet, but just remember we have factoring, but not everything's factorable. We have completing this square, which works well a lot of the time. Some of you will prefer that method over the quadratic formula. We have the square root method, which really only is good for certain types of quadratics. Um, well, and other polynomials. I think the one thing we need to make sure we understand is that in this unit, we're solving all kinds of equations, and the quadratic formula only works for quadratics. So it only works for quadratics. So, don't try to use this on a cubic or an x to the fourth or something like that because it doesn't work. Um, we're going to make sure that you're comfortable with this method, but it honestly is not going to be your go-to method on most quadratics, but I guess I'll let you decide that. So we're going to just dive right in. First of all, like factoring, we have to have the set equal to 0. We have to have our function set equal to 0, so you might need to move some factors over. So that happens. We are going to just be plugging and chugging and simplifying radicals. And step 3 is going to be new to you. So we're going to make sure I cover that well enough for you. All right, so let's jump in. Let's do it. Okay, this one I need to subtract 10 over, right? X squared plus 3x minus 10 equals 0. I'm not going to do this on every problem. I'm just going to do it on this first one. A is the leading coefficient. Just here's your a squared, or your a, here's your b, here's your c. A is the coefficient of x squared, b is your coefficient of your linear term, and c is always your constant. Okay, notice that's a negative 10 there. All right, so we're finding our roots, our zeros, our solutions, and if they're real, meaning they're not imaginary, those are going to be x-intercepts. So here we go. The opposite of b plus or minus b squared minus 4 times a times c all over 2 times a. X equals negative 3 plus or minus. Okay, so remember PEMDAS, you got to do your multiplication first. So I just kind of, order doesn't matter, so I'm just going to kind of do negative 10 times 1 is a negative 10. Negative 10 times the negative 4 is positive 40, and then plus 9. So that's going to be 49. Perfect squares are lovely. And let's simplify that. That's negative 3 plus or minus 7 over 2. Now, remember, because it's an x squared, we are looking for 2 solutions. So make sure that you are identifying 2 roots here, okay? So this is negative 3 plus 7 over 2. So that's 4 over 2, which is 2. Oops, sorry, that equals 2. And then negative 3 minus 7 all over 2. And that's going to be a negative 10 over 2. Sorry, my pen has disappeared. Here it is. Negative 10 over 2, which is a negative 5. So please make sure you put your solutions in squiggly braces like we've been doing for all of our other equations when we're solving. Okay, number 2. Make sure you write x equals every time, please, because this is an equation. Opposite of b, I guess I can write positive 6. Plus or minus. Remember, it doesn't mean it's in the formula. That doesn't mean negative b. That means the opposite of whatever b is. B squared minus 4 times a times c. Okay, 4 times 1 is 4. 4 times the negative 4 is 16. Let me try that again. I didn't do something right. B squared minus 4 times A times C. Oh, not, that's a negative 16, sorry. 4 times 1 times 4, that's a negative 16. So 36 minus 16 is 20. All right, so we have a radical. This is going to be a radical that we need to simplify. So this is 6 plus or minus 2 root 5. If you need to, if you don't know what square root of 20 is, I mean, we do it a lot. This is a very common radical. So what, I don't know, 2 and 10, and then 2 and 5. And you got this, oh, got a pair of 2's. So that's 2 root 5. Okay, so this is the next step, the final step, sort of the final step. You need to split it. And I don't mean like split like we did on number 1 here, where we split the plus and then the minus. That is not at all what I mean. It says if your final answer has irrational or imaginary parts remaining, it should be written as a sum or difference of the two parts, not in one big fraction. So right now, you've got one big fraction. So what we're going to do, let me take another color. What you're going to do is you're going to split it into that. Oh my gosh, and that, sorry, that was very messy. So we're going to do 6 over 2 plus or minus 2 root 5 over 2. Again, we're not splitting the plus from the minus. We're splitting because our denominator is a monomial, meaning it's one term, you're allowed to split this fraction up into two parts. So this is 3 plus or minus root 5. And I'm just going to put braces around it now. So one answer is 3 plus root 5. The other answer is 3 minus root 5. We're not going to be using any decimals or anything like that. When we, even when we graph, we're not going to be working with decimals. So just leave it in radical form. If you want to separate that into 3 plus root 5 and 3 minus root 5, go ahead. I'm not going to do it, but it's not wrong if you want to do it. Okay, so again, you put the first term over the denominator and then the second term over the denominator, and just make sure you keep the plus or minus in between them. Okay. All right, so let's try another one. And we're going to have several examples like that, so don't freak out. We're going to be fine. You're going to be fine. All right, this one looks like we don't have a 0 over here. Let's go ahead and subtract 15 and add 7. Is this as skinny as I can get it? Let me try that. I'll make that a little skinnier. Okay. 20x and then add 7. So that's 25 equals 0. All right, so x equals the opposite of b plus or minus b squared. 20 times 20 is 400 minus 4 times a times c. I know those numbers look big, but I promise you it's going to come out beautifully. Over 2 times a. All right. So 25 times 4 is 100. 100 times 4 is 400. So 400 minus 400 is 0. So this is x equals 20 over 8, which reduces to, let's see, 4 goes into that, right? 4 goes into 25 times, 4 goes into 8 twice. Okay, so what does that mean? I only get one answer. Well, you know what that means? It means, you know, we have to have 2 answers. Doesn't mean they have to be 2 different ones. This is a double root. And I just want to show you real quick. This one right here is factorable. That factors into 2x minus 5 and 2x minus 5. Okay, so we get 5 halves for each one, but that is factorable. 2x and 5 minus 5 and 2x minus 5. All right, let's keep going. We change colors. All right, x equals, sorry, we need to subtract. Oops. I'm rusty with this pen today, sorry. All right, so we have to subtract 5. Okay, x equals the opposite of b plus or minus b squared minus 4 times a times c all over 2 times a. All right, -5 times a -1 is +5. +5 times 4 is 20. So 16 minus 20 is a -4. All right, so we have to simplify this. We have a nice little perfect square underneath that radical, but it is imaginary. You got to pull out an I. So this equals -4 plus or minus 2i over -2. Now, we have to split our answer. All right, so I'll do this again. Split it into that and split that. So -4 over -2 plus or minus 2i root 2i over -2. And listen, you don't have to show every single one of these steps. Okay, I'm just trying to show you how to split these. So some of you can probably split that in your head. -4 over -2 is +2 plus or minus. And then this 2 can cancel. Now I know it's weird to have this negative down here, but it actually doesn't matter because it's plus or minus right here. So it's plus or minus -i or plus or, so it doesn't matter that there's a negative here. So this is plus or minus I. Put those in braces, please. 2 plus or minus I. Okay, all right, let's move down to the next one. Looks like we have to get it equal to 0 again. All right, so -12x squared. Oh my gosh, I'm struggle busing today. Make sure you write it in descending order. Okay, so let's see, how do I want to do that? I think I like to do -4 times the -12 is 48. +48 times 2 is 96. So this is 25 plus 96. I'm going to have to write that down. Over -24. So that's 121, which is lovely because that's a perfect square. All right, so here we go. X equals, I'm going to go ahead and split. Actually, no, I'm not going to split that. -5 plus or minus 11 over -24. All right, so that is -5 plus 11 over -24. Oh my gosh, I can't write. So that's going to be 6 over -24, which is -1/4. So there's one solution. All right, the other one's going to be -5 minus 11 over -24. So that's a -16 over -24. All right, let's see, 8 goes into that. 8 goes into 16 twice, and it's negative over negative, so I know my answer is positive. 8 goes into 16 twice, 8 goes into 24 3 times. So our solutions here are -1/4 and 2/3. All right, let's get this last one in, and then we'll talk about the discriminant. Okay, 100 minus 8 is 92. I think we better do a factor tree for that. Let's come over here and do a factor tree. 4 goes into that. 4 goes into 9 twice. 12. 4 times 23. So that's 23. All right, so x equals negative 10 plus or minus 2 root 23 over 4. Okay, now we're ready to split. I'll show the splitting again. I split. Oh, I'm trying not to get the plus and the minus because we still need that. So negative 10 over 4 plus or minus 2 root 23 over 4. And we can reduce both of these fractions. That's going to be a negative 5/2 plus or minus root 23 over 2. I don't know why I just did that brace. Negative 5/2 plus or minus. Okay, so I don't know why I changed the thickness, so it looks weird. Okay, so there are your two solutions for that one. Okay, so we have some irrational solutions here. Up here we have some rationals. The blue one, we have a double root. It counts twice. Here we have two imaginary roots, 2 plus or minus I. And up here we have two irrational roots. And this first one was two integer roots, which is nice. Okay, so the next thing we're going to do now is talk about something called the discriminant. Got a couple rules to try to learn. Okay, all right, here we go. The second part of this video deals with the discriminant. Not discriminate, discriminant. See, there's an N in there, right? Basically, if you look at the b squared minus 4ac, you know that that is the part of the quadratic formula that is underneath the radical. So there is no square root on these, okay? No square root. It's just the expression that's underneath the radical. And what that expression tells us, it says, or tells us what type and how many are the solutions, okay? What type are they? So when you do the discriminant and it is greater than 0, meaning it's positive, okay? Right, positive. When it's positive, okay, there means two real solutions. If I'm going to come over here, well, no, sorry, I'm a little frazzled here. If that answer is a perfect square, then they're rational. And if you guys remember what rational means, it means you can write it as a over b. Okay. And if it's not a perfect square, it's irrational. It could be a radical. It tends to be a radical often. But remember, a rational can be written as a over b. It's not can be written as a fraction or an integer or a number that has a decimal has a repeating pattern or terminates. If the discriminant is equal to 0 when you calculate it, there is only one solution. It's one real solution. The way I remember that is the word 1 has a 0 here. That's how I remember that when I first learned this. And then when the discriminant is negative, when it's less than 0, there's two imaginary solutions. Okay. All right, so here are 6 examples here. And we're going to say how many there are and what type. All right, so if the discriminant, you go to calculate b squared, my pen is not working at all. My pen has stopped working. Where are you? There it is. That's positive, right? Positive 10. If the discriminant is 10, there are two real solutions, and that is not a perfect square, so they're irrational. Those two are irrational, but they're real. 121, that is a perfect square. It's positive, so there's two, they're real. But because it's a perfect square, 11 squared, they are rational. If the discriminant is a -5, there are two imaginaries. I don't know if I need a new battery in my pen or not. Sorry. If the discriminant is 0, there's one real solution. If the discriminant is 3, that means it's positive. There's two real. And that's not a perfect square, so they're irrational. Here's another perfect square. It's positive, so two real. And these are going to be rational. All right, so that's going to make a difference when we start graphing these. When we do the discriminant, that will help us determine how, if we are going to graph them or not. If they're imaginary, of course, we don't graph those. Let's go ahead and do some calculations. Again, there's no square root when you do the discriminant, okay? So it's b squared minus 4 times a times c. 36 minus 36 is 0. So there's one real solution. And it's gonna be rational. It's gonna be rational. I don't think I wrote that up at the above. B squared. Six times 4 is 24. Subtract those, and you're going to get 25. So it's positive, so there's two reals, and these are going to be rational. We'll just do a check mark. B squared minus 4 times a times c. Okay, 36 minus, let's see, 15 times 4 is 60. That answer is negative. So these are two imaginary, and those are not going to be rational or irrational. They're imaginary. Remember, those are two separate number systems. Real numbers and imaginary are totally separate. Okay. All right, last three examples. B squared minus 4 times a times c. 49 minus c, that's 36, right? 12 times 3 is 36. Just 13. So those are real because it's positive, but they're irrational because it's not a perfect square. B squared minus 4 times a times c. 4 minus 16, that's a negative number. Two imaginary solutions. Actually, sorry, I meant to put a 2 over here. And then here, b squared is 256 minus and that is going to be 256. It's 256, so you get 0. There's one real solution, and it'll be rational. Okay? All right, so there we go, because, yeah, I'm just going to leave it at that. Okay, sorry I rushed through that. Hopefully this is enough to send you on your way for success. Thanks for watching.